Hello everyone, welcome to APNIC e-learning. Today's e-learning session is going to be on DNS concepts. In this session, we hope to discuss about the concepts of DNS. And to introduce myself, my name is Champika and I currently work as the training unit manager at APNIC. Now let's move on to the topics that we hope to discuss in this session. Initially, let's look at what is DNS and what are the DNS features. Then we will go on to discuss about some of the definitions and terminologies, such as domains, zones, and so on. Also, we will spend some time discussing about the namespaces. And then we will go on to discuss about name servers. We'll have some more details on DNS name servers, and then some of the features where we will be focusing on. And then finally, some details on the performance aspects of DNS. So these are the overview that we would like to discuss during this session. Now let's have a look. What is DNS? Now, as you can see, DNS is a mechanism to translate one type of resource to another type of resource, or you can call objects, for example. In other words, what we are trying to do is we try to map one type of resource to another. For example, we can map a name to an IP address, and so on. So why do we really need DNS? Now, when you think about the data communications, that happens, of course, in the IP level, whereas when you have the IP address, that is fine, so you can send the data from one particular host to another particular host. But then why do we have to worry about DNS? Because as we know, we are humans and it is difficult for us to remember the IP addresses. So that's the main purpose why we have the DNS, so that easily we can use these names to address our hosts. Now, DNS is quite useful in various situations or in various services. For example, like even if you want to visit a certain website, or even if you want to send an email and so on, we do use DNS regularly. Now, looking at the DNS, you can call it as it's a globally distributed database, or what we can call as a namespace. Now, there are features like loosely coherent, because even though it's globally distributed, we have to make sure it's all intact. And also it should be scalable. When the DNS namespaces grow, we need to make sure that it allows that scalability factor. Also, we have to make sure it is reliable in case if one of these namespaces are not accessible, we should be able to access an alternate namespace. So in other way, it should be reliable. Also, it is a dynamic database where it should be possible for us to update this database or namespace dynamically. Now, considering all these factors, DNS can be comprised into three important components. So what are those components? The first one is what we call a namespace. As I mentioned you earlier, you can call it a database if you like, or even if you want to go into further detail level, you can even call it as a file. That's where we do the configurations, or what we call a zone file, when you get into the very details of that. So we have a namespace, and this namespace has to be properly organized structure so that we can organize our names according to a proper structure, so that in that way we should be able to define a certain hierarchy so that these names can be accessed in a proper way. So that's the main purpose of the namespace. Now the question is, who is going to provide this namespace? So we have a namespace, you can call it a database, as I said. So who is going to provide this database or the namespace? So for that, we need to have these name servers. So that's where the name servers comes into the picture. So we have the name servers that keeps the namespace. Next question is, okay, you have the name servers, they keep this namespace. For what? For what purpose? That is for the clients. So the clients or the resolvers in DNS terminology, they ask questions from these name servers. So that is why the name servers, they need to keep this namespace. So whenever the client or the resolver asks the question from the name servers can look into that namespace and then give the appropriate answers. That's the whole purpose. So everything about these DNS things, what we're going to discuss, is actually based on these three big components. First is the namespace, then the name servers, and then the resolvers or the clients. So DNS is a critical infrastructure or critical internet infrastructure. We can define it in that way as well. So let's move further. Now these features, earlier I briefly mentioned you, it is a globally distributed database. Basically, it can help us to share the load and also the administration as well. It is also loosely coherent. In other way, it is globally distributed, but we still have the coherent. And it is scalable. Also, we can add the DNS servers without affecting the entire DNS. That's what we call scalable. Also, as we define here, it is also reliable. In case, we talked about name servers earlier. So when we have these name servers, in case one of the name servers, let's say, goes down, is not accessible, we should be able to find the answers through another name server, for example. Right? So that's reliability factor. So we try to achieve that. It's a feature of DNS. And then we have the dynamicity, a feature called dynamicity. That is to modify or update changes, all these things you can do in a dynamic way, right? So this is kind of covered under a separate area called dynamic DNS. So these are some of the very important features that what we have in DNS. So let's go more into the details of a namespace. Earlier I mentioned you about the namespace, and also I told you that these namespace need to be structured properly in a proper hierarchy or a proper organizational structure. Now you can see in this diagram you have a tree structure properly organized. On the top you have root, and then you have a next level which consists of number of what we call top level domains or TLDs. So always in the DNS hierarchy on the top we have root, and remember these are all namespaces. So who keeps the root namespace? We have the root servers to keep the root namespace, and then we have the top level spaces. They are being kept at top level servers, top level domain servers, TLD, right? So nowadays we have over 300 of these top-level domains, for example, like .net, .com, and so on. Then we also have country code top-level domains, or what we call CCTLDs. They're also kind of top-level domains. So overall, we have more than 300 of those. And this is at the moment, this is currently, but in the future, there are processes that ICANN is currently working on with regard to some of the new generic top-level domains. So we might have some new generic top-level domains in the future. And then we have our next level. So in this example, you can see that .NET, that's the top level. Underneath that level, we have APNIC. So the namespace is going to be apnic.net. And further down, you can create another level, and so on. So that's the hierarchy that we are talking about. It's kind of a tree hierarchy here. Everything is properly organized. And these top-level domains are, again, they have a certain meaning behind that. So, for example, you can .NET can contain organizations or network operators, networks, and so on. So similarly, commercial or .com can include commercial organizations. So you can define certain proper structure. And geographically, let's say some organizations belong to a certain country, can come under that country code top-level domain, right? So these are, this is how this structure is being created and built. So we have a terminology here called FQDN, as mentioned in the slide here. FQDN. So what is FQDN? FQDN is fully qualified domain name. So in other words, we're trying to define the full path with respect to this tree hierarchy. When I say full path, that includes all the way up to the root. Now, if you want to think about, let's say, the web server of APNIC, that can be defined as www.apnic.net. So it should end with a dot, in other words, a trailing dot. What's that dot? That's basically to define the root. So when we define the root, in other words, when we define all the way the absolute path of that hierarchy all the way from the root, this is what we call a fully qualified domain names. Especially when we get into configuration level, it is important to define this dot. Missing a dot can create configuration errors and so on. So that is why, especially this representation is quite important. So that's some information about this hierarchy. Then we also get into some of the other terminologies. Let's look at this term called domains. So what are domains? Now, domains are namespaces. Earlier I defined what do you mean by really a namespace, right? So domains are, in other words, namespaces. So you can, as I said, you can create this hierarchy. So we can create these namespaces. And different parties can be responsible for different namespaces. You don't have to keep the whole DNS namespace in one machine or a server or in one place. We can have one part of this namespace in one location and another part of this namespace in another location. That's the whole purpose, because here we are talking about a distributed database or a distributed system. So the domains are, in other words, they are namespaces. Okay, let's move forward. Now you can see, if you see this diagram, now there is a certain part is highlighted in blue, and that is, in this example, it is defined as the net domain. So it's a namespace And here, according to this diagram, it is defined in blue color. So that blue area is what we call the net domain, or in other words, the namespace of .NET, right? So net domain. So if you really see that, it's everything below the net level is what we call this net domain. Everything below that. If you consider apnic.net, that's going to be below .NET. So that's part of net domain. Or if you consider training.apnic.net, still it's below that. So overall, if you consider everything below .NET, is considered as the net domain. And similarly, there is another top-level domain, or a country code top-level domain, .au domain. So everything below AU is AU domain. It's another example. Now this is a subdomain of .NET. So apnic.net. So everything below apnic.net is, again, it's a namespace, and it is coming under .NET. Right. Then we have this term called delegation. Now, what is delegation? In our real life, how do we define delegation? If you want to give part of your responsibility to another party, that's what we call delegation. So in the same way, if you are responsible for a certain domain or a namespace, and if you want to give part of this to another party, or if you want to delegate part of this to another party, this is the idea that we are talking about. So delegation is you're giving part of your responsibility to another party or an entity. When we do this, we call it as delegation. We can do this based on various factors. For example, that can be done based on a geographical region, based on an organizational affiliation, or different other purposes. It's up to you. If you're responsible for a certain namespace, you can do based on your requirements. So the administrator of that namespace can handle this, can delegate this responsibility. Now, there are a few things what you need to think about. If you delegate, if you give your responsibility to a certain party, then that other party is responsible for that delegation. What you need to know is how to actually keep contact with the other party that whom you delegated the things. The actual work need to be done by the next level, the child level. So here we are talking about a parent and a child level kind of relationship. So parent makes a delegation to a child, and then the things underneath the child will manage by itself. What parent needs to know is how to get to the child. In case, let's say, if there is some question which related to that child space, the parent will send the request to the child so the child can answer. Okay, so this is the importance of this situation. Now let's get into the fact about zones. Now what are zones? Now we talked about few definitions earlier. We talked about the namespaces, then we talked about the domains, and then we talked about delegations, and now we come to the point of zones. So what are these zones? Zones are administrative spaces. Now earlier I defined that domains are namespaces, but in the case of zones, they are administrative spaces. I also mentioned you earlier, now once I have delegated part of my responsibility to another party, I need to know how I get to that party. But that other party, my child party, is responsible for the things inside that namespace. So if I want to get to know, if I need to know how to get to my child namespace, that's where the administration comes in. So that's where the zones comes in. So what do you have in your zone? How you get to your child zones or child spaces. That is what we have in our administrative part or administrative zone. So zones are administrative spaces, and the zone administrators, they are responsible for a certain portion of the namespace. And then they can delegate the authority, as we discussed earlier, they can delegate the authority from parent level to the child level. Now let's try to analyze this situation further. So this is the diagram we had earlier. You can see the hierarchy. You have the root, then you have the top level domains, and then also you have the next level domains and so on. Now this is the net domain what we discussed earlier, the blue area. And then similarly, this is the apnic.net domain, which is a subdomain of .net. And the .net zone is going to be that red area, right? So that is the administrative area. So that's the area what we call the zone or the net zone. So this is a very important concept where if we have to understand these terminologies in a correct way. And similarly, we can define our apnic.net zone in the same way. We have a delegation from apnic to training. So beyond training, that doesn't include into the zone of apnic, because once apnic has delegated the training to another party, they have to look after, the child party have to look after the data inside that delegation. Whereas in this example, underneath apnic level, you have whois, you have ww. So these are the information that is related to the administrative space of apnic, and of course the delegation of training. So apnic.net needs to know how to get to training.apnic.net. And similarly, if you consider about the training.apnic.net zone, that's the bottom example, the last one. Alright, so those are the information related to the namespaces, domains, zones, delegations, and so on. Now, if you remember those three big or the important components we discussed earlier, the first one was the namespaces, that's what we just discussed. And then I mentioned you that who keeps the namespace, that's name servers. So what type of name servers we have? And what is the purpose of these name servers? Name servers are there to answer the questions. Questions of what? The questions that are being asked by the clients or the resolvers. So the resolvers ask these questions from the name servers. So name servers need to keep these namespaces and answer the clients or the resolvers. So there are different types of name servers we discuss. First is what we call authoritative name servers. Authoritative name servers. What do you mean by that? They are authorized to give answers, or reliable answers, you can say. Generally, we have these terminologies called primary and secondary, or in some documentation you might find master, slave, is the same thing. So let's call it primary and secondary. So our primaries and secondaries are basically our authoritative servers. So they are authorized to give answers for that particular namespace. And then we have another type of name servers called caching or recursive name servers. What are those? Now, in the case of these type of servers, they can, based on a reference, they can go and contact many other name servers to find the answers. That's what we call recursive, right? So recursive servers get a referral from another name server, and then go and contact or talk to another name server, and so on. This process can continue until it finds an answer. So once it finds an answer, then comes to the point where it keeps the answer in the memory or in the cache. That's where it comes. That's where we discuss about the caching name server. So it is kind of a caching name server. It keeps the answers in the cache. So there are, of course, we can configure some of these servers as a mixture of these functionalities as well. So you can configure a name server that can act as a authoritative server as well as a caching or a recursive name server. Okay. So that's some basic information about the name servers. Now let's see how these DNS queries happen. Now earlier I mentioned that DNS is useful. I mean, we use DNS to, let's say, some applications like, let's say if you want to visit a certain website, HTTP type, right? If you want to visit a website. Now what you do is you visit the website and then you download the web page. Now for you to visit the web server, you need to know in the first place the IP address, because that's where the communication happens, that level, the IP level, right? So I need to know, if I need to visit a certain website and download the web page, I need to know the IP address of that web server, right? So if I'm the client. So how this client, now in this example, you have a client there. Now this client wants to visit a web server which is www.example.edu.au. Now let's see how this client, what sort of process that this client is going to go through. Now we have our hierarchy, the DNS hierarchy, which we discussed earlier. So you have the root level, the root name servers. Then you have the next level, which is the top level domain, TLD level. So you have .net, .com, and so on. So these are all these TLD servers. And then also, of course, we have our CCTLD servers as well. For example, .sg for Singapore or .in for India, and so on, right? So you have all those CCTLDs. So you have all those name servers for that top level. And now our client is trying to find the IP address of that www.example.edu.au, because that's the IP address of the web server that it wants to visit and download the web page. So this query goes to the local DNS. Let's say the IP address it's looking for is p.q.r.s in this example, right? That's an IPv4 address. In real life, this could be something like 203.1.176.something.something. Okay, so let's assume that it's p.q.r.s. So in other words, that's what we have to find, but we don't know it is yet, right? So what we want to find is the IP address of that www.example.edu.au. So that's the question that this client is asking from the server. So server simply has to find this IP address in DNS. So it is a process now. This DNS server, the local DNS server, has to query through various other DNS servers in DNS and then try to find this IP address, which is p.q.r.s, and give that to the client, right? So how this local DNS is going to find this IP address? First thing is, in case if this local DNS server has that answer in the memory or the cache, it can straight away give the answer to the client. That is why we have the cache. But let's assume there is no cache. I mean, this IP address is not in the cache, and it's some new question that this client is asking. So what will the recursive server will do, or the caching name server will do? It will go and talk to root name server in this case. Why it's talking to the root name server? Because root name servers are the servers that located in the top of the hierarchy. And root servers can give a reference. That is why the root servers are being contacted. So there are quite a lot of root servers scattered around the world, and these local DNS will contact the nearest root server it can find. Right? So the query now goes to the root name server, but if you really see, the answer or the question is related to finding this www.example.edu.au. So the root server, if you try to see exactly what the question is, it's way below the root hierarchy. So you have the root level, which is the dot level, and then the next level is going to be the top level, something like .com, .net, or a country code. So root is not going to give the answer exactly for this particular question. Instead, root will give a reference. So root will give a reference asking our local DNS to go and contact the top level server, which is in this example, it's .au name servers. So the local DNS will go and talk to the .au name servers and ask the same question. Now, the local DNS has received the IP address or the IP addresses of .au name servers through root, because root give the references. How the root can give the references? Because root has got delegations to those top level domain name servers or that namespaces. Okay, so root servers give a reference, and then our local DNS or the recursive name server can go and talk to .au name servers in this scenario. Now these .au name servers can be scattered around as well. In other words, they are the primaries or secondaries of .au. Okay. Now the question is again the same question. Give us the IP address of www.example.edu.au. Now this has been asked from the .au name servers. Still, if you see the hierarchy, it's below, it's way below. And .au name servers know there is a delegation from .au level to edu.au level. So the answer is kind of a reference now. So it is giving a reference, go and talk to the next level, child level, which is edu.au. So our local DNS will ask the same question again. Give the IP address of www.example.edu.au. Answer is going to be pretty much in the same way. It is a reference to the next level, which is the example.edu.au. Then our local DNS, the recursive. Now this is what we call the recursive process. It goes and talks to the next level, example.edu.au. When I say it goes and talks to the next level, that means basically to the name servers. It goes and finds the name servers and asks the same question. Give the IP address of www.example.edu.au. Now once it goes to that level, example.edu.au, now that's the zone of example.edu.au. In other words, that the name servers that are being contacted by the local DNS are the authoritative servers of example.edu.au zone. These can be either primaries or secondaries. In other way, these name servers should be able to give an answer, a reliable answer. So in this case, now the name servers of example.edu.au will give an answer, because that answer, which is the record related to www.example.edu.au, the IP address belong to that name, is in the zone of example.edu.au name servers. So the answer is received by the local DNS, and it is being given to our client or the resolver. Now once the resolver gets the IP address, it knows the IP address, now it can establish the connection. After that, what happens is our local DNS or the recursive name server can keep this answer in its memory or in the cache, so that in the future, if another client or a resolver comes and asks the same question, it can straight away give the answer by itself. It doesn't need to go and talk to these other name servers, the roots and TLDs and so on, until that the cache remains. Now as a zone administrator, in this scenario, the zone administrator of example.edu.au can define that time that answer should be kept in the cache. This is what we call TTL, time to live value. We will come back to that later. Right? So the local DNS, our recursive server, can keep that answer in the cache for a certain amount of time, that what we can define, so that the clients who comes to that recursive name server to ask questions about that particular IP address within that limit, they all can get the answer quickly. They don't, because the recursive server doesn't need to go through all this hierarchy and talk to all these name servers. So this is how the query process, DNS query process happen. Okay. So just to simplify, what we discussed now is simply we define this in this diagram as well, the same example. So resolver went and talked to a caching recursive name server and asked the A record of www.apnic.net. Earlier what we discussed was a different A record, www.example.edu.au. Now in this case it's a different name, www.apnic.net. The same process. Right? What we're looking for is the A record, IPv4 address. The query goes to root name server, and then to the next level, the GTLD server, and then to APNIC server in this example, right? Because we're asking something inside apnic.net zone, and then get the answer from apnic.net authoritative servers and returns that answer to the client. After that, the answer is kept in the cache of recursive name server. Okay, so that's how the DNS queries happen. Now let's go more into details of our zones. Right? Now we talked about these authoritative name servers because I told you that they are authorized for that zone. Now the next question is, okay, what is inside the zone? Right? What is inside the zone? Now zone is you can call it as a database if you like, right, or a file. So what we have are really resource mappings, or in other words, resource records. So we try to map one resource to another type of resource. So what we have inside our files or database are all resource mappings, and they're called resource records. Now you can have so many different types of resource records, but all these types are organized again in a proper structured way. What kind of structure are we talking about here? Now we have got 5 fields in this structure. Now those 5 fields are listed in the left column you can see in the slide. Label, TTL. TTL stands for time to live, type, and R data, resource data. And then the right side has got the function of that. Why do we need a label? As name substitution for a fully qualified domain name. And similarly, what is a TTL? That's a timing parameter. That's the expiration limit. Class. Now, historically, there were a few other classes, but now we use the internet class, which is defined as IN. Now, this is a default class, so whether you write the IN or not, it will assume as IN. The name servers knows that it is IN class. The type, there are various types as I mentioned you. For example, like A records to define addresses, IPv4 addresses. Quad A, which is what we call Quad A records to define IPv6 addresses. MX records to define mail exchanges, mail servers. PTR records to define pointer records. And TXT, SOA. There are many types of resource records for different purposes. Then the last field is what we call RData. Now this is the last field where we include the exact values for that record. So we'll have some examples for all these different types. Now these are some of the common resource record types. Again, just to stress that these are not everything, right? These are some important resource records. A record, as I said, is to define an IP address. So if you see here, we have A record, which is a mapping between a name, right, and an IP address, IPv4 address. So we define that using A record, type A. And similarly, IPv6 address, that's the name of the let's say the web server in this case. And this web server has got an IPv6 address. So the resource record is going to be something like Quad A. NS, type NS we use for defining a name server. So this is the name server name, ns1.apnic.net. You can see there's a trailing dot here. Why do you need a trailing dot? The last dot, that is to define the fully qualified domain name, including the root. So what we are doing here is we are defining the name servers for a zone apnic.net. Even here we specify the fully qualified domain name. Okay. And then, so this is why we use NS record. Now this is an example where how we use pointer records, PTR. PTR pointer records are used to define reverse zones or reverse mappings. I won't go into too much details about the reverse mappings because we have a separate e-learning session, e-learning class where we discuss about reverse DNS delegations. So if you are interested in knowing more about reverse zones, how you can create these reverse zones, please feel free to attend our e-learning session on reverse DNS. CNAME is another resource record type where we use to create an alias. Right? So in this case, in this example, you can see we have a web alias for www. And similarly, MX resource record, this is a type where we define to, we use to define mail exchanges. So you have different mail servers here. You can also define some kind of priority here, right, with these values. So these are all different types of resource records we can use in our zone for different purposes. Now, we also have a resource record called SOA. Now, SOA stands for Start of Authority. Start of Authority is a very important resource record again. Always we define, when we write a zone file, we have SOA record on the top. We start writing the zone file with a SOA record because SOA resource record contains all the administrative information. Things like your zone, things like your name server, email, contact details, and also timing parameters for the secondary and so on. So this is a typical format of how the SOA resource record looks like. You have your zone, and then you have a class. This is the type, right? SOA is the type, and then your name server, it's a name, and then your mailbox email, and then these values are for your secondary name servers. Remember earlier we discussed about authoritative name servers, primaries and secondaries. So these values are for that purpose. Now you might wonder, why do you have to have all these values here? Whole purpose, what we are trying to achieve here is the reliability factor and then consistency, of course. So you have, in case if our primary name server is not accessible, still we should be able to serve our zone using our secondary name servers. You can have one secondary server or multiple secondary servers. More the servers you have, obviously you have more redundancy there. But again, then you'll have to think about other factors like performance factors. Okay. So let's assume that you have one primary name server and one secondary name server. So in this scenario, we also have to make sure that both primary and the secondary, they are consistent. They serve the same information. Otherwise, if the primary is serving one type of information and if the secondary is serving total different things, it's not going to work well, right? That's not correct. So that is why it is important for us to make sure that the primary and the secondary, they're serving the same zone data. So we have to make sure the zones, they are consistent. They're serving the same information. So how are we going to achieve the consistency? That is why we have these parameters. So first of all, we have a serial number, right? We have a serial number. The idea of serial number is to we try to achieve this consistency through a serial number. So let's say if I am the primary server, I have a certain serial number, and then I have a secondary name server, let's say yourself. So you are the secondary. So how can we achieve the consistency between myself and yourself? So I have my serial number, and when first time, of course, you talk to me and you get my serial number. This is what we call a zone transfer, right? So once you get my zone, we both have the same serial number because you got my zone file, my zone. And then once I add some new things to my zone or delete some things from my zone, in other words, if I do some changes to my zone, I have to make sure that you know that what changes that I have made. How I'm going to achieve this? What I'm going to do is I'm going to increase my serial number. When I increase my serial number, when you come to me next time, you're going to compare the serial numbers between us. So you will compare your serial number against my serial number. And when I increase my serial number, you know that, oh, my serial number is something higher than yours. So this is where the zone transfer triggers in. Because you know that my serial number is higher, so you will get my zone, or you will do a zone transfer. So when this zone transfer happens, after that, again, we are consistent. Because you got my zone, you have the same information as I do, and also you have the same serial number as myself. So we are consistent each other. So that's why we need to maintain a certain serial number. Now again, on a different note, this serial number, you cannot just put anything what you like, right? Because there are some certain limitations and some certain restrictions. It is a 32-bit number, so you can have maximum of 10 digits in that. So what we try to use is we use a convention here, and the convention is usually the year, month, date, that format, and then you have another 2 digits for your sequential updates. So you have 4 digits for the year, 2 digits for the month, another 2 digits for the day, another 2 digits for your the sequential updates, right? So you have 10 digits there. So that's all about what you need to know about serial number. But if you need to know more about these serial numbers, there are further information you can read and so on. Okay, and then we come to the next one, which is the refresh. in the resource record, the refresh value. So what is this refresh value? Now earlier I mentioned you that secondary name server comes to myself, so yourself, if you're the secondary, you come to me and then check my serial number, right, whether I have increased my serial number or not. Now that time gap, that time duration that you come to me is what we call the refresh time. So after if every refresh time, the secondary comes to the primary and check the serial number. So the refresh time. So after every refresh time, this process happens. So that is why we have to define a refresh time. And then let's say the third thing is retry. Let's say if I'm not contactable, if the primary name server is down for some purpose, for some reason, if the primary name server is not contactable, then the secondary server will retry to achieve this. It will come and retry. So we have to define a certain time duration again as a retry value. Let's say if you give refresh time as 12 hours, for example. Now after every 12 hours, secondary comes and try the primary. We can define something like maybe 4 hours as the retry value. So after every 4 hours, it will try to, contact the primary again. Then the next question is, how long do you think that this process will happen till the world lasts? No, right? We have to, stop at some point. That's where we need an expiry, right? So we have expiry so that the secondary will stop this process. So after that, this one will not be served. So this is why, the purpose of these values. And then we also have here another minimum TTL value, or what we call the negative cache here. So that is actually if you want to keep the secondary for negative answers for a certain amount of time. Okay, so these are the timing parameters for the secondaries. These are again some examples of what we have already discussed in the previous slides, the TTL timings and so on. So you can either define these in seconds. So in this example, let's say 7,200 seconds, that is equivalent to 2 hours, or you can define in like 2H. So then usually the name server softwares understand this. Okay. So once you combine all these things and try to put together into a zone file, this is how it's going to look like. I mean, this is the sample zone file. Now, in actual fact, these zone files can be very, very large, right? It can contain so many records and so on. But this is just a very, very brief or very small zone file. So you have a few records here. You can see there's a SOA record here, there's an NS record here, and then there is a record, and so on. Right. So also you can see, remember the 5 fields that what we discussed: the label, the TTL, the class, the type, and the ArcData fields. So all those fields, they have got values. So the label, there's a label here, www.apnic.net. Actually, there should be a trailing dot here. Then we have a TTL value, class, IN, type A, and then the resource data. That's the value of the IPv4 address in this example. That's this one. Okay. All right. So far, then we talked about up to the zone files and so on in the name servers. Then we get to the point. Okay, the performance factor of DNS. Because if we are going to implement all these things in our DNS infrastructures, we also need to consider the performance factor. Now, if it all depends on your server hardware requirements. If you have some latest software, latest hardware, you can definitely get better performance. And at the same time, if you're running some old hardware, if you're running your name server in a very old system, old hardware, there can be performance issues. Operating system also matters. There are some operating systems They take more resources. Some operating system with even minimal resources, you can run these name servers quite well. So operating system and the DNS servers running, these are also factors for the performances. So there are a lot of DNS servers out there. There are lots of DNS server softwares. Some of those are open source type of software. Some of those are commercial softwares. So it all depends on your requirement and the type of DNS server that you would like to run. But the point here is that some DNS servers can perform well in certain environments, and some might need more resources, and so on. How many DNS servers you are running? Or if you run a number of DNS servers, as I mentioned you earlier, for reliability and so on, you can always do some load balancing, sharing, and so on. Okay, scalability factors as well. So how many DNS servers you run? How many zones expect to load? If you have a lot of zones, it takes more resources to load those zones. If you have fewer zones, it can load quickly. These are all reasons for performance aspects. How large the zones are. Sometimes you might have even fewer zones, but if they're very large, if they have lots and lots of records inside those zones, it will take time to load those. So the performance issues can occur. So that is why it's important that you need to consider these factors before you implement your DNS infrastructures. Zone transfers. This is also one of the important factors. Now you have all these primaries and secondaries. You might have multiple secondaries. If you have multiple secondaries scattered around, they, after certain time duration, remember refresh times, they come and do these zone transfers from the primary. They get the file from the primary. So if all these number of secondaries get this own file from primary, there will be lots of transactions happening between your primary and secondary name servers, which needs more resources. Otherwise, there can be performance issues. Where these DNS servers are located, even when you put physically your name servers in, I'm talking about from a network level, even that also can be a factor for your performance. If you put it in a proper place, maybe for example like exchange point, so you can get some better performance there, right? Bandwidth, right? Bandwidth factors. I mean, obviously, if you have bigger bandwidth, you'll get better performance there. If you have very slow bandwidth, you'll have issues, especially if you do a lot of zone transfers and so on. So these are all reasons behind, reasons why your performance can be affected. Also, are these servers are multi-homed? That means connecting to multiple upstream providers. Or how many interfaces are to be enabled for listening? Because if you're going to listen, you might be having lots of interfaces that these DNS servers could be listening to. In that case, it will need more resources, it will need more memory and so on. If you don't have that, it can affect the performance. How many queries are expected to receive? If you're going to have lots, if you're having a very busy name server, if you're answering quite a lot of questions for your clients, if you have a lot of clients, a lot of resolvers, they're asking very regular, very frequent questions, you will need more processing and more resources to answer those questions. Recursion. If your name server at the same time running as a recursive name server or a caching server, if your name server is going out and talking to root name servers and going out and talking to top level domain name servers and many other name servers, it needs more processing power, it needs more memory and more resources and so on. Otherwise, there could be performance issues. Dynamic updates. This is another area. I told you that DNS can be updated dynamically. But the thing is that we need to be very careful if you implement dynamic updates, because there could be always bogus updates. So that is why we need to do some checking, some authentication checks before you allow these updates. So if you have to do that, definitely you need to implement some authentication mechanisms, which needs more resources again. Right. DNS notifications. Now, this is a scenario where if you don't want, let's say your secondaries come to you after certain refresh times, and if your secondaries need, if you don't want, if you want your secondaries to know the changes quickly enough, then you can send notifications to your secondaries, so they don't need to really wait until that refresh time occurs. So in the middle of the refresh time, you can send a notification. In case if you have done some update, you can send a notification. The primary can send a notification to the secondary, so that the secondary can come and do a zone transfer, right? So these things are always good, because then you can keep your DNS up to date. But the downside is that you need more memory and more resources and so on, better bandwidth and so on, right? Otherwise there could be some performance issues. So all these factors need to be considered, especially if you're going to implement DNS or if you're going to actually manage your DNS infrastructures. Okay, so this is what we wanted to actually go through during this session, very introductory session, where we discussed about DNS concepts. Now, the things what we discussed in this training or in this session are, we talked about some basic concepts of DNS, what is DNS, and what are the important things like namespaces, name servers, right, the features of DNS, and also we discussed about the different types of namespaces, things like we have the domains or these namespaces, the hierarchical spaces. And then we discussed about the administrative spaces, zones, the delegations, how we can delegate one zone or one space to another party, parent-child relationships. So these are all important things. Then also we went through things like your DNS servers, name servers, different types of name servers, authoritative name servers, recursive name servers, or caching name servers. And what do you mean by authoritative name servers? The primaries, secondaries, how do we keep this consistency, reliability factors. Then also we went through the recursion process, how the DNS queries work, how they happen. The queries come to the recursive name servers, and then they go and talk to root name servers, and then to the next servers, and so on, and how the answers are given, how they keep the answers in the cache. All these things we discussed. Right. Then also we went through the zones, more detail into the zones, what are there in the zones, the resource mappings, different types of resource records, fully qualified domain names, different types of records like A record, COD A record, PTR records, NS records, and so on. And then how we can map those different fields, right, the labels, the TTLs, the classes, and so on, right, different fields. And also more about the performance factors as well when you implement this DNS. So I hope that this session was useful to you, especially in terms of understanding some basic concepts of DNS. And also, if you have any further, any questions related to some of these aspects, feel free to talk to our help desk. We have a help desk chat line as well. More information can be received from